Hello, good evening. My name is John Barnes, and I will be covering class CYB-505, topic 3, data at rest, in use, and in transition. I apologize, my webcam's not working correctly tonight, so we're just going to talk through this. So to get right into it, we're going to be talking about data at rest, data in use, and in transition. Okay, these three states are important to remember when dealing with cybersecurity because at any given moment, data is not simply doing just one thing, it could be doing all three of these at the same time. It's being stored, it's being transferred, it's being processed all at the same time. As a result, each state has unique vulnerabilities that require different security controls. Protect one state, attackers will exploit the others. In this presentation, I will define each state of data, talk about what the biggest threats to each state are, and discuss how security looks different for each state. So the first one on the list, data at rest. What is data at rest? So that's our stored data, our hard drives and database backups, our cloud storage. It can include laptop, hard drives, databases stored in organizations' data centers, backup setting in storage objects, removal drives such as USB drives, old school CDs. Although data is not actively moving across networks, it is still vulnerable and attractive to attackers. The biggest risk for this data at rest is unauthorized access, whether this happens through theft of a device, improper access controls allowing users access they shouldn't have, malicious insiders, or misconfigured cloud storage backups. Most companies use full disk encryption, database encryption, and access controls based on the least privilege principles. Encrypting disks and database helps protect these data that should not uh, fall into the wrong hands. Coupled with access controls, this makes it more difficult for attackers to access in cryptographic keys that are used to encrypt the disks or database. Next, we have data in transit. What is data in transit? We got our data moving across our networks, our emails, internet traffic, and server-to-server communication. Data moving across the internet is considered data in transit as this data is moving inside a private internal network. Examples include web browsing, sending or receiving emails, API calls between services, transferring files, and so on, including internal traffic between servers inside a data center. Data in transit can be attacked as it flows across the communication medium. Network sniffers can be used to capture packets or perform man-in-the-middle attacks against communication streams. Encrypting this data while it is in transition is the most common method of providing data confidentiality. Encryption protocols like transport layer security, better known as TLS, encryption packets before they travel across the network. If they are intercepted, they will not be viewable by attackers. You can use virtual private networks or VPNs. They provide encryption tunnels to connect remotely with other networks. Certificate management and hardening against attacks by encrypting using of secure protocols is another common method using to ensure data in transit is properly secured. Network security is generally more important than dealing with data in transit than with data at rest. Last on the list, we have data in use. Data in use means that the data is currently being processed by an application or function within the system. When you access a document on your computer, your phone, run a query against the database, or log into application, decryption occurs and files need to be opened into system memory or your RAM for active processing. Endpoint security policies can become tricky because the data needs to be vulnerable to your device or application that is processing that data. Attack vectors commonly used during this time are memory scraping, malware, key logging attacks, privilege escalation, and through applications with known vulnerabilities. Prevention is commonly done through endpoint detection and response platforms, runtime security, monitoring, access control policies, and application hardening. Some organizations leverage hardware security features built into modern CPUs, such as secure enclaves, trusted execution environments, which help isolate specific processes. Typically, prevention and protection is not encryption based, but uses detection, behavioral analysis, and minimal privilege uses. How security strategies changes. Attackers will often try to exploit whichever phase provides the least security. By knowing where your data resides, we can better protect it. For data at rest, our security controls should focus on securing our storage. Encryption access controls, physical security, and configuration management are all key concepts to remember. For data in transit, our security focus transitions from network security, TLS, encryption channels, and certificates are all things we want to think about when securing data in transit. When data is in use, we care more about runtime protections and monitoring, as well as limiting privileges. It's worth noting that encryption isn't as big of a deal for data in use. This is because uh, the system needs to decrypt the data in order to use it. As you can see, there are many different ways we can protect our data.